Hello everyone and welcome to this short video on how to calculate the area of circles and sectors. So we're going to start looking at some formulas that we use with circles and sectors, and those formulas start with the area of a circle. So the area of a circle, as you can see on the screen, we have our circle. Let me bring up my pen. You can see that on the screen we have our circle here. You can see that this circle goes round and round and round and round and round. And we have also got the radius of our circle. So the radius of our circle, that radius of our circle is the important part of our circle that we need to know about. So the formula itself is A for area. A for area, and then there's pi. So it's our Greek letter pi. And then it's just the radius squared. So that's the radius times itself. And that's just how you do that circle. The next one is an annulus. An annulus is like a ring or a donut. So it has two circles involved, an outside circle or a larger circle and an inside circle or a smaller circle. So we have a slightly different formula for this one. We're still using the outside boundaries, but this time we have a large radius. So the outside circle. If I've spelled that correctly. And then there's the little r radius for the inside circle. So that's the inside circle. So it's the same basic idea, only this time we have that subtraction in there because we don't need that bit in the middle. We just need between the outside and the inside. That's all the bit that we're worried about. So again, A for area. A for area, we have our pi symbol. And then we have our outside circle or our outside radius squared. And then we have our inside radius squared. If I can get this pen to work. Okay. Next thing we need to look at is the area of a sector. The area of a sector. So again, we have a formula. This time we're still looking at that radius there. So we have our radius still squared. And this time though, we don't have a full circle. We don't even have half a circle or a quarter of a circle, but we don't know how much of it we have. So what we have here is we have the 360 degrees of the whole circle for the denominator. So that's the whole circle denominator. And then up the top, that's our theta symbol. And theta just represents the size of the angle that we're working with. And that gives us the proportion of the circle that we're dealing with. So it just gives us that small part, piece of the pie, if you will. Next, we have the semicircle. Semicircle is merely just half of a circle. So that is just half of the pi r squared. And a quadrant, well, a quadrant is a quarter of a circle. So now it's just a quarter of pi r squared. So they're those formulas. They all work pretty well. Using pi in our circle, pi has a lot of relationships with the circle, and you're free to go on and investigate all those relationships. But right now we're just using them to find the area of these shapes. We have some examples here. Our first example, we're calculating the area of the shaded sector in both of these examples. So our first one, we need that area of a sector. So we want A equals theta over 360 pi r squared. So remembering that that theta represents that angle inside of what we're looking at. So for this one, we want 135 over 360 times pi times the radius. We don't actually have a radius given on our question here. So let's give it a radius. Let's give it a radius of, let's say, 1, just to make life a little bit easier for us. So now it's just going to be times 1 squared, and then we can work that out. So we just have our calculator here down the bottom. And as you can see, we have all the keys that we need on here. We're going to start by finding our fraction key. So let's find our fraction key. There's our fraction key right there. I'm going to get that up. I'm going to type in my 135 at the top. I'm going to go down and I'm going to go to 360. And then I'm going to get out of my fraction. Okay, so make sure you get out of the fraction. Otherwise, everything happens in that denominator and not where it's supposed to be. We want to go times now. So we want to hit that times key. We want pi, so we're going to need shift. So shift's all the way up here. I'm going to go shift pi times, and we want 1 squared. So we now find our squared key down here. That's all we have to do. And then we hit equals. Now this is giving us 3/8 over, or 3/8 pi. Or we can just get 1.1780 ... And if we round that off, so we want 1.178097, and it keeps going because pi obviously is a number that keeps going. And then we just want to round that off, so to 2 decimal places. I'm going to have 1.1. I look at that number after the 7, it's an 8, so it needs to go up to 18. All right, now I don't have a unit of measurement on this particular question either, so we're going to just use the words units squared. Okay, just using units squared. So get that organized. Okay, let's have a look at the next question, that second half of that question. That second half of that question is another sector area, but this time we actually want what's in the shaded bit, not the bit that we've been given the angle for. So that angle is 60 degrees, so we need to do 360 for the whole circle, minus 60 for that bit in the middle that we don't need to find the area of, and obviously that's going to give us 300 degrees. So the angle we want to use is 300 degrees, okay? And then we just go through the same process as we did with question 1. So we want A equals theta over 360 pi r squared. Now I always write the formula down first because it just helps to know where I'm putting my numbers when I start putting numbers in. And so recommended that as you're starting out that you definitely do that. And then as you're getting more proficient, perhaps you don't need to do that as much. So this time we're going to have 300 over 360 times pi. Now you can see in this question has a distance for radius, distance being 15 meters. So it's going to be 15 squared. All right, so now we just do exactly the same thing in that calculator. Get our fraction key up. We're going to get 300 over 360. I'm going to take the times now times pi. So remember that shift pi back to times, and we're going to have 15 squared. All right, hit our equal sign, and again we have this 375 over 2 pi. To get our number up like we did before, we have this special key here that is the standard to decimal key. It is standard being fraction form to the decimal form. So when we click that key, it changes it for us from that fraction form to the standard form, which is very, very useful. So here we're going to have that 589, and it's going to have 0.486, and it's going to keep going. To 2 decimal places though, we're going to have 589 point, and we're going to have 0 because 0 is the first decimal place. 4 is that second one. We look to the next number. It's an 8. That's 5 or above. So 4 becomes a 5. And we do have units of measurement for this one. This one's in meters, so we need to go meters squared. Okay, and that's the second example. Hopefully you have got those in. I'll just move up so that you can actually see those responses. Sorry about that. Next one, we have to calculate the area of the following shape. All right, so calculate the area of the following shape, correct to 1 decimal place. So now we have a composite shape. We have a composite shape there. So I'm just going to break it up into 2 separate shapes. So I'm just going to go down here, and now I have a rectangle and a semicircle. Okay, and I just have to add those 2 areas together once I've figured them out. So area of a rectangle is just the base times the height, and in this case that's going to be 30 times 24. And just use my calculator to work all that out. So I have 24 times 30. It does not matter which order these go in. This is multiplication. You're going to get the same answer either way. So that's going to be 720. And again, that's going to be meters squared. So that's the rectangle portion taken care of. And then I want the semicircle. So the semicircle is just a half of pi r squared, as we saw before with our formulas. So again, simple mathematics there. I'm going to get up my fraction, 1 over 2, get out of the fraction, times pi, times, and this time our radius. We need our radius. So the radius is half of 24 because 24 is the whole way. So 12 is going to be our radius. So we're going to put in 12 and then squared. Hopefully you all understand where the 12 comes from. 12 being half of 24. 24 being the diameter of our semicircle. Again, just need to hit that S to D button, and we're going to get 226.1946. Continuing on. Now, we need to add those 2 together. My recommendation is do not take anything off that screen. So the whole area of the shape will be the rectangle. The rectangle plus the semicircle. Because you've got the semicircle already up on your screen here, just add the rectangle to it. So just add that rectangle to it and hit equals. So now we have 946.1946. Continuing on. So always round at the very, very end of your maths. It gives you a far more accurate approximation or answer in terms of that rounding, because you haven't rounded too early. So here we want 1 decimal place, so 946. And of course, that first decimal place, the next number along is a 9. So that 1 has to become a 2. And then, of course, we've got meters for our units of measurement, so meters squared. Alrighty, are we ready for the next one? Just comfortable again. So our next one is that annulus that we spoke about before. It's the annulus. So the annulus being that larger circle and a smaller circle on the inside, and having that distance in between the 2. Okay. Again, what we have here is a diameter. So that's the diameter. What we want is the radius. Therefore, the radius is going to be 30 divided by 2 because the radius is half of a diameter. So we're going to have a diameter of 15 for that big radius. Here again, we have another diameter. And again, we need that radius. So this time it will be half of 12, or 12 divided by 2. Obviously, now this one's 6. Okay, so now we have our two R's. We're ready to attack this problem. So A equals, and now if we scroll all the way back up, we will see what's going on. But all it is just pi. All right, and then the large circle radius squared minus the small circle radius squared. Okay, hopefully that makes sense to people. I'll just move that back across. So now all we have to do, plug in the numbers that we need. So we've got pi, again, in a bracket outside of that bracket. And now we want 15 squared minus 6 squared. And we can just use these bracket keys. To help us put this together. So I'm just going to go Shift Pi, and then open up a bracket, go 15 squared minus 6 squared, close my bracket off and hit equals. I'm getting that standard form again, so I just change it to my decimal form. I now have 593.7610. Continuing on, 1 decimal place is what we're after. So 593.8 this time, because that second decimal place is a 6. The one in front needs to go up 1. So it's 8, and then again, we're in meters, so meters squared. So hopefully this has helped you develop some understanding on how to find the area of circles and sectors, including the annulus. Thank you for watching.